Hello everyone, so today we will see unit 3 of Spark code running in Fabric. So use Apache Spark in Microsoft Fabric. So just go through statement by statement here. To edit and run Spark code in Microsoft Fabric, you can use notebooks or you can define a Spark job. So either notebooks or using a Spark job. So to edit and run a Spark code, Microsoft Fabric, you can use notebooks or Spark job. Notebook. So when you want to use Spark to explore and analyze data interactively, use a notebook. Spark to explore and analyze data interactively. Okay, use a notebook. So you need to remember this point. When you want to use Spark to explore and analyze data interactively, use a notebook. Yeah. So interactive basis notebook is needed. Notebooks enable you to combine text, images and code written in multiple languages to create an interactive item that you can share with others and collaborate. So interaction with others and collaboration also you can do. You will combine text, images and code written in multiple languages to create an interactive item that you can share. So this is a sample screenshot of the notebook. You see the code, right? So from PySpark SQL type import, okay, everything, order schema, struct type, struct field. So this you are defining a table. So spark.read format CSV schema order schema load. So all the CSV schema CSV files are loaded and display.df data frame. It is a data frame. df is a data frame. Notebook consists of one or more cells, okay, each of which can contain markdown formatted content or executable code. So it's just, this is the one. So it is a row by row. Okay, this is called as a cell, but row by row. Each of which is marked down formatted content or executable code. So you can just remember it as a code. Marked down means it will go down. Okay, you can run the code interactive notebook and see the results immediately. Spark job. If you want to use Spark to ingest and transform data as part of an automated process, just like a job, right? Like an ETL job or ingestion job, you can define a Spark job to run a script on demand or based on a schedule. So run a script or based on a schedule. So you can see here the Spark job, right? So here when you go to Microsoft Fabric, the data engineering, you can see the Spark job. So you can file to upload, you execute on a scheduled basis, or a file to upload, right? Python. So upload, that will execute. To configure a Spark, create a Spark job definition in your workspace and specify the script it should run. You can also specify a reference example. For example, Python code file containing definitions of functions. So in reference to the specific lakehouses containing the data, that the lakehouse contains the data that the script processes. Okay. So there is an exercise as well, so we can look into that in the next one. But going through the unit 4, work with data in a Spark data frame, DF, right? So how? Natively Spark uses a data structure called a resilient data distributed data. It is very important. Spark uses a data structure called resilient distributed data. But while you can write code that works directly with the most commonly used for structured data is the data frame. Data structure resilient distributed data set. Work with RDDs, most commonly used is data frame, which is provided as part of the Spark SQL library. Data frames in Sparks are similar to those in the ubiquitous Pandas Python library, but optimized to work in Spark distributed processing framework. Pandas framework you should be knowing in Python library. It is specific to data analytics, but it is optimized in Spark distributed framework. In addition to the data frame, a Spark is note. Okay, in addition to the data frame API, strongly typed dataset API that is supported in Java and Scala also. Data frame API. Okay, in this module we will focus on that. So let's explore hypothetical examples how you can use a data frame to work with data. Suppose you have the following data in a comma delimited CSV file. the file loader in your lakehouse. Like this is the inferring a schema. So in Spark Notebook, you can use the following Spark code to load the data, file data into the data frame, display the first 10 rows. So you see that limit. So PySpark, you need to use this in the notebook. Spark.read.load files.csv format csv editor will display. Limit 10 rows. Spy line at the beginning is called as magic and tells Spark as the language uses PySpark. You can select the language you want to use the default in the toolbar of the notebook interface, then use the magic to override the choice for a specific call. For example, here's the equivalent Scala code for the product. Spark, it's a Scala, right? Spark.read.csv option header true load displayed limit again. So it's almost similar to Python, but yeah, it is a Scala syntax. Magic Spark is both of these codes will produce output like this. Okay, specifying an explicit schema. So in the previous example, the first row is contain the column names, correct? And the Spark was able to infer the data for each table from the data it contains, correct? You can also specify an explicit schema for the data which is useful when the column names aren't included, not included. Like the CSV example, so there is no column name. Following Spark code, PySpark example, how to specify schema for the data frame, schema for each column. Okay, for this format, for the format above, which does not have the column names. So from PySpark.sql the types.import star, all the types are imported, all the functions are imported for SQL. Product schema struct type, struct field product ID integer, string type, float type, gf spark.read.load, files.product csv, format csv, product schema, header false, header is false, right? So display limit. So it will, we are defining the data type for all these fields. Okay. So this is the syntax of the PySpark code here. You get these files. Filtering and grouping data frames. You can use the methods of the data frame class to filter, sort, group, otherwise manipulate the data. So these are all transformations, right? Filter, sort. For example, the following code example uses select method with the product and list price column from the df data containing product data in the previous example. Use the methods of the data frame filter, sort, group, otherwise manipulate. For example, the following code example uses the select method to retrieve the product ID and list price columns. Only these two columns will come from this data into this data frame. Something like this. Okay. In common with most data frames, select returns a new data frame object. Okay. Selecting a subset of frame is a common operation which commonly used in the following shorter syntax. And also use this syntax also. You can chain methods together to perform series of manipulations that result in transformed data frame. This is the transformation. Chain methods. For example, this example code change the select and where methods to create a new data contain the problem at a mounted mix. Chain methods means you are employing filters here now. You are seeing, right, how it is df.select product name category, these three columns where df category is equal to this, double equal to, always in Python, PySpark, the display. It is from the code example, so it will filter out this particular. To group and aggregate data, you can use the group by method. Aggregate function. For example, following PySpark code contains counts the number of products for each category. So group by, for each category count. So for each category you will get the count. Just like the SQL, saving a data frame, you will often want to use Spark to transform data and save the result for further another downstream process. So saving the result. Following code example, save the data frame into a Parquet and Delta. There are two types of in the data lake. Delta lake tables are more performance oriented, okay, but we will see what is the difference in the further subsequent sessions, what is the difference between Parquet and Delta, how you can improve the performance in the Delta, in the data lake, and integration to data breaks, all those, okay, replacing any existing file of the same name. So the same name it will like, so it's in the file format, right? Data lake is file, not the relational, because it has to store the unstructured data. So the Parquet format is typically preferred for data file that you will use for further ingestion into an analytical store. Parquet is very efficient format that supported most large scale. In fact, sometimes your data requirement simply be to convert data from other format to Parquet only. So we'll see what is Delta and Parquet. Partitioning the output file. Partitioning is the optimization that enables Spark maximum performance across the worker nodes. So as we spoke about the Spark, it has a Spark pool nodes, driver program, and the executor program. Yeah. So it is a heavy distributed parallel processing. More performance can be achieved when filtering data in pairs by element unless disk IO. So you can split those files into partitions. To save a data frame as a partition, use a partition by method. When writing the following example, save the value of data frame, product data for the monomer, and partitions the data by category. So you see here partition by category, mode overwrite, parquet files by data. Save a data frame in the partition and use a partition by method. When writing the data, the following saves the bike data frame, okay, which contains the product of mountain bikes and road categories, okay, because these are the two columns that we use, and filters also, right? And partitions the data by category. Partitions the data by category, partition by. Mode override means the same file you can overwrite, and it's in the form of a parquet data, and this is the file name. We are just giving the file name. The folder name generated when partitioning the data frame into the partition column value in a column to show the code example creates a folder like bike data that contains following subfolders. So these subfolders will be created. Folder name generated when partitioning a data frame including the partition column value in a value equal to format equal to value, so that the code creates a folder name bike data that contains the following subfolders. So you are creating two partitions based on the category. These are the two subfolders. Each of one of the product data for the appropriate category. See, for this mountain bikes, there will be data that will be in one partition. Road bikes is one partition, because you are using category as a partition. Okay. Each subfolder contains one or more bucket files with the product data for the appropriate category. You can partition the data by multiple columns with a hierarchy of folders for each partitioning key. So it becomes complicated again when you are partitioning more and more columns. For example, you might partition sales order data by year. So the folder hierarchy includes a folder for each year value, which in turn contains a subfolder for each month value. You got it, right? So it's like a hierarchy. Load partition data. When reading partition data into a data frame, you can load data from any folder within the hierarchy by specifying explicit values or wildcards for the partition field. Loads data for the road bikes category. Okay, so here road bikes data frame, read parquet for category road bikes into this one only and display that only. For the limit 5 means first 5. The partitioning column specified in the file path or omitted in the resulting data frame. So this is an important one, important sentence. Partitioning columns specified in the file path are omitted in the resulting data frame. The results produced by the example query will not include category column. The category would be road bikes. Because here you have only road bikes, it will not create the partitioning column for category, because not in the road bikes only, we already defined road bikes. So why there is a specific differentiation in category will not work. Okay, so this is what we covered in the two sections, two units. So first is how to run a Spark code in the notebook, okay, and also create a Spark job definition and how to automate that. And the second one is how to work with the Spark data frame. In the next unit, resilient data, distributed data set or data frame. How will you load and from the CSV file, and how would you transform using the Spark, creating partitionings, filtering, grouping, aggregating, saving a data frame, partitioning the output file on specific column, how multiple columns, how to load the partition bikes into partition data into the data frames. So all this are covered. So we'll cover next two units in the next session. Thank you.